Good morning, and welcome to this webinar with the Pacific Institute for Climate Solutions. I'm Sybil Seitzinger, the Executive Director of PICS. And first, I'd like to start by acknowledging and expressing my respect for the Wakungan peoples on whose traditional territory PICS's main office on the University of Victoria campus stand, and the Songhees, Esquimalt, and Waisanich peoples whose historical relationships with the land continue to this day. In the chat, I encourage you to introduce yourself and share the territory where you are today. Before we get into our session today, some very brief comments on our Zoom webinar space. You'll see the chat function, which is enabled today, so feel free to share comments and engage in discussion as we go. For the question and answer period after the presentation, please type your questions into the Q&A window. You can find the Q&A button at the bottom of your screen. So with all that sorted, let's get going. Today, we're going to dig into PICS's latest report, Survive and Thrive, Why BC Needs a Carbon Dioxide Removal Strategy Now. This report comes at an opportune time for British Columbia as our provincial government and our citizens wrestle with how to make its commitment to net zero by 2050 into a concrete reality. The report's author, Dr. Devin Todd, PICS's researcher in residence on negative emissions technologies, is here today to walk us through the report. He will explain why negative emission technologies, or NETs, are an indispensable part of meeting BC's commitments, the opportunities NETs offer, and why a strategy for NETs is necessary in BC immediately. We'll take questions after his presentation. So for now, over to you, Devin.
All right, thank you. All right, can someone tell me if my screen is showing?
Good.
All right, let's get started. Okay, so today I'm going to be talking a bit about the net context, the idea of co-production, as well as strategy guidance. So first, a bit about PICS. PICS is a collaboration amongst the four major research universities in BC. Those are SFU, UBC, UNBC, and UVic. PICS was created by an endowment from the province of British Columbia, and our mandate is to produce leading climate solutions research that is actively used by decision makers to develop effective mitigation and adaptation policies and actions. So we do this with collaborative partnerships, what we call co-production, which connects solution seekers with experts from the research community. Research partners come from the four PICS universities, but they can come from other institutions as well. Solution seekers can be from most anywhere. That includes governments, public or private sector organizations, Indigenous communities, and more. What's common is that they need some help to make informed climate decisions. PICS sits at the intersection, where these groups come together to advance climate solutions that are linked to climate action. So the range of topics that PICS has supported is broad, reflecting the complexity of climate action, from energy to the built environment to policy, not only around mitigation, but also on adaptation and resiliency. The newest area in which we have developed projects is in negative emissions. Negative emissions remove greenhouse gases from the atmosphere to bring overall emission rates to zero or even negative. This is the topic of today's discussion. So here's a quick example of a PICS-funded negative emissions project. Solid Carbon is the recipient of PICS's first $1 million Theme Partnership Program award. The Solid Carbon team is developing a negative emission technology that aims to capture CO2 from the air, stick it into the basalt geology beneath the sea floor, and there transform it into rock, where it will remain locked away. Now, the Cascadia Basin off the west coast of Vancouver Island is the best place to launch this solution. That's because it's one of the best understood regions of subsea floor geology, and project proponent Ocean Networks Canada has the know-how and existing infrastructure backbone to monitor its performance. Now, the next step for Solid Carbon is to put together a demonstration and refine the details of a larger scale expansion. But why am I talking about Solid Carbon? Solid Carbon touches on themes within the report. It's a real local example of potential within the negative emissions technology space. It models thinking broadly about how nets might fit within the world. So the team is not just building a widget. We're integrating perspectives from engineering, natural and social sciences, law, business and economics, and beyond. Solid carbon also models the strategic long-term investments we need to make if we're to have enough climate solutions. However, solid carbon is just one big idea. We need more. So here's my quote here. 39% of US adults said they haven't seen, read, or heard much about carbon removal practices, while another 34% have consumed nothing at all on the topic. So I don't think we're much better here north of the border, so it's reasonable to say we have an awareness issue. This brings us to the report, whose goal is to provide some orientation for the negative emission space. Now, this is motivated by too many gaps being in the net discourse, which is something that has rocketed in popularity in the context of net zero goals. The report itself is aimed at a broad audience of thought leaders and decision agents within government and industry. From a policymaking perspective, it addresses the ideas of problem definition and agenda setting. It also sketches out how formulation and decision-making might be approached. However, what the report does not do is assert a specific policy or technology implementation for the province. So straight to the conclusions. The recommendation is to create a strategy. We cannot meet our climate goals without nets. Meanwhile, BC may be endowed with the know-how and resources for nets, and that might be enough to meet our needs or even become a world leader. But we first have to answer why, how, under what conditions would we do that? So that brings us to needing a strategy that'll work. While we have some promising net solutions already, we need to scale up what we have, improve on it, and yet still develop new ideas. This demands a strategy that breaks out of silos and brings participants together. Overall, BC needs to encourage innovation and build capacity in a way that is sustainable for the long term. So the report itself is roughly organized into 3 parts. In blue, it covers what nets are, why we need them, and what makes them special, as well as how our current path may pose problems. Orange covers an argument for building capacity through a catalytic community. And in green, we offer guidance on strategy formulation. So part 1, what's the deal with nets? Because nets may be relatively new for the audience, I'm going to dwell on this part the most. So how do we get to talking about negative emissions? This comes about from Paris goals, BC's net zero pledge is consistent with those goals, as well as our best knowledge on what that will take. Now, most of the world has already advanced net zero pledges. However, folks may not realize that a pledge for net zero greenhouse gases is an implicit pledge for negative emissions. So how does that come about? This illustration shows how negative emissions fit into the big picture. I'd like you to notice some things. First, we need massive reductions in gross positive emissions. That's the green getting bigger and the brown getting smaller. In blue, we need a small but growing deployment of negative emissions capacity already in the near term. The red dot is a milestone where we hit net zero emissions. The ongoing red line is net negative total emissions to compensate for historical emissions or delayed action. And finally, notice the ongoing blue of negative emissions to compensate for residual positive emissions in brown, extending beyond 2050. Also notice some things that negative emissions are not. Negative emissions are not the green stuff. They're not positive emissions reductions or efficiencies. They are not renewable energy, electrification, decarbonization, or other low carbon intensity stuff. Those are all good ideas, but those are not nets. So what is a net or negative emission technology? These are the means to get negative emissions. Another word you might have heard is carbon dioxide removal, or CDR. Carbon capture is another word that also gets thrown around, but that can mean very different things depending on the context. The simple summary is that nets extract CO2 from the atmosphere and lock it away for a long time. Now, nets themselves can look very different from each other, so when considering what is and is not a net, it helps to keep some questions in mind. First, where is the carbon from? Is it coming from the air? That's okay. Is the carbon coming from fossil sources? That's not a net. If the carbon is coming from residues or byproducts from other industries, now that's going to depend. Where does the carbon go? If it's going into the ground, that's okay. If it's going back into the air, such as with fuels or carbonated beverages, that's not going to be a net. Is where the carbon goes permanent? So carbon has to be locked away robustly. And for some solutions, that's going to mean indefinite stewardship. And lastly, was the act intentional and additive? Is there a climate benefit relative to the no intervention scenario? Do all associated releases and drawdowns add up on a life cycle basis? And then how will that hold up when we scale up a solution? And how about when the rest of society itself is net zero compatible? So this might seem easy enough, but diligence is required to ensure that something is really a net in practice. There can be edge cases without clear answers and even some dubious claims out there. So this illustration shows several practices with net potential. Now, some of them share similar building blocks with each other and or other abatement practices, for example, carbon capture, use and sequestration and ecosystem management. Now, looking at this illustration, keep in mind these are very generalized groupings. The details of a particular solution and the context of its deployment can make or break feasibility. It's too much to talk about each one here in a single report or presentation. But what I do want to stress is that negative emissions technologies are much broader than just the direct air capture or DAC, as you might have seen in the media. So how much negative emissions do we need? That's going to depend. It's going to depend on how fast we reduce positive emissions, how far we eliminate positive emissions. In other words, how much residual emissions do we compensate for in perpetuity? It also depends on how much risk and responsibility we are willing to impose on others across time and space. Now, many estimates work top down, starting with a 1.5 degrees Celsius target, IPCC scenarios, as well as modeling. We then take this big number for the world, and then we consider different distributive principles for allocating those to different jurisdictions. Now, in this case, BC might require about a half to a couple gigatons of CO2 cumulative removals by 2100. Alternatively, we could think bottom up, which starts by asking what are our current emissions and how much of those are hard to abate. In this scenario, BC may need about 24 million tons of CO2 removals per year, or about 1/3 of 2018's emissions. Yet another perspective is to consider, oh, no, didn't want to do that. Yet another perspective is to consider nets as an economic opportunity. Now, not all jurisdictions can may be able to meet their needs domestically. Meanwhile, in Canada and BC, we may have an outsized potential. This flips the question around. How much do we need becomes how much are we willing to live with or exploit? The bottom line here is that the numbers are big, but wide-ranging. We need to establish what we want for the future and translate that long-term confidence into near-term action. Now, the concern is that in developing negative emissions technology capacity, we may repeat past mistakes or fail to anticipate the new problems that nets may introduce. Now, unfortunately, we do not have the luxury to fail, as we've already done so for decades on the climate file. So some features of nets that might merit departure from usual climate action thinking include greenhouse gas removals are not reductions. So removals can scale, they can scale independently from each other, and there is no substitute for removals. CO2 removal from the atmosphere is fundamentally an energy or material expense. Absent a regulatory or voluntary market incentive, there is no immediate value for the net practitioner. Now, if we allow it, nets can also sever the relationship between greenhouse gas emitting activities and action to directly abate those emissions. This is like the current trade in offsets, but provides a more credible mechanism. Nets also have no shortage of challenges. A few cross-cutting ones include massive scales being required, and this is certain to result in resource competition with other components of a sustainable future. We also have barriers to action and siloed efforts, where current incentives risk delays and shaping unfavorable long-term net portfolios. We also have inertia behind business as usual. Nets might be seen as a fix to avoid disrupting current greenhouse gas intensive practices or investments, and that could set nets up to fail. Finally, the governance space is generally underdeveloped. So these are, we need to rise to these challenges. Unfortunately, we're not doing a good job of that. The current situation is an underdeveloped patchwork of regulatory and voluntary action. I would argue there is insufficient public leadership, and where it does exist, it is anchored in non-negative emissions technology thinking and priorities. So for example, thinking in terms of CCS at point sources, or in terms of conservation. Now, on our current trajectory, the scales that we have for negative emissions are woefully insufficient. There's nothing deployed really yet. Priorities also may not be aligned again with a sustainable net future or sustainable future or a net portfolio. Eventually, too, we have to consider that there may be no more polluters left to pay for the nets we need. And how are we going to handle that situation? So just to highlight a few indicators, right now, we recognize the importance of negative emissions durability, but many protocols only look ahead 100 years. We also have confusing public messaging out there. For example, there at the federal level, we have the 2 billion tree commitment, which claims a drawdown benefit, but we need to know more about how much and how lasting those drawdowns are actually going to be. In the United States, we have the 45Q tax credit, which places point source carbon capture as well as some nets under the same policy umbrella. Now, they've improved that recently in the past few months. However, it still leaves those nets in the point source CCS policy crossfire, because a lot of that point source CCS is affiliated with hydrocarbon development. And that brings us to oil and gas companies, who are currently moving to lay claim on capacity to offset production and consumption. Now, that alone does not support net negative goals. I'd also like you to consider the implications of a land rush on limited ecosystem-based capacity, which is the lowest hanging fruit that these organizations are seeking to subscribe to. Overall, instead of looking for long-term sustainability, we risk selecting for lowest cost, attractive, but only short-term cash flows. Now, in summarizing part one, I hope you agree by now that BC needs a strategy for the net sector. Part two explores how we might build better capacity for developing and pursuing a net strategy. Now, a lot of the building blocks for nets are actually not new. The pieces are just waiting for an enabling environment. So I'll give you a second to read that. All right. So the good news is that the most recent climate plan update, Clean BC Roadmap to 2030, is already drawing on some potentially helpful ideas. In short, it's to build flexible institutions for more coordinated research, development, demonstrations, and deployment or diffusion. Now, what the report does is reinforce this with some additional net considerations. And it's best encapsulated in the last sentence of a second quote here. And the idea here is that this kind of strategic collaboration is as much about the process as it is the content. So how do we get there? The report organizes this into three ideas. Firstly, we need a community to do it. Those are the people and organizations with outsized capacity, potential, or responsibility to build the future of nets. This means assembling at least the net solution developers and project proponents. That's the obvious group. But we also need the help from public and private finance. We also need to bring in the net value chain participants. Those are the organizations associated with the supporting technology, materials, energy. We also need policymakers as key custodians of a net strategy and who must ultimately generate the demand on behalf of the public interest. The idea is a co-production model can break down some of these barriers within and across these groups. Secondly, we need a supporting environment to mobilize net technologies and the entities pursuing them. Instead of waiting for a sector to self-assemble, which might end up being beholden to business as usual, we could be seizing the creative opportunity to build the sector we want. So what to do? Near term, we need to develop deeper understanding of negative emission technology status and potential. Too often, we conflate economic measures, such as market share, with the whole. Instead, we should be engaging in the granular detail of economic, technical, social acceptance, and legal and regulatory considerations. What we need to do is to tailor initiatives which cover journeys from concept to commercial scale deployment. Thirdly, we need to be more ambitious, and that's what I would call an entrepreneurial ethos. This is to buck our current incrementalism trend and our historically weak approach to climate action. In doing this, we might consider that we need to manage downside potentials, but also assume enough strategic risk or opportunity to achieve our climate goals. I'd invite you to consider negative emissions technology as a climate change hedge and not just a sectoral mitigation tool. In doing this, we need to work with the uncertainties inherent with climate change, climate solutions, and society's trajectory. And part of addressing that is going to be needing to adopt a willingness to experiment. Now, this means valuing learning through success and failure and investing towards that at meaningful scales. Overall, in summarizing part 2, my suggestion on building net capacity is don't just build nets, but rather build the system, the environment, the relationships, the processes that will build us nets. So, having framed negative emissions technologies and how we might approach the innovation, part 3 shifts to strategy formulation. In the report, we explore crafting a vision for nets, principles by which to operate, and some policy considerations. Now, the goal is not to advance a particular implementation, but is to provide examples to broaden the idea space on how nets might fit within the rest of society. A final caveat is that any strategy will need to be established alongside an appropriate public participatory process. So a vision establishes our expectations for nets. This is something which must be consistent with the rest of a sustainable future. While thinking ahead to something like 2050 might seem abstract, it really isn't. Ecosystem-based nets may take decades to reach peak productivity, whereas built net facilities, such as direct air capture, might have multi-decadal lifetimes. What we create today will stand for a long time. Now, BC has an opportunity to establish itself as a leader by striking an ambitious vision for nets, and it needs to be ambitious because achieving net negative greenhouse gases demands urgent and substantial negative emissions capacity. Because the success of nets hinges on how it works alongside the rest of society, you'll find the suggested vision components cover a broad scope. Now, establishing a set of net principles gives us a compass to navigate decision-making in an environment of uncertainty and of divergent priorities and values. The report's suggestions are too many to read off here, but a couple of themes arose. First are the hard greenhouse gas numbers that define our climate goals. Second is how do we build sector capacity? And third is around the challenges of governance. As the report organizes it, these ideas are overlapping. So you can see the colors overlapping in the diagram here. And I'd also like to point out the hard numbers, the orange part, is only a small part of the bigger picture. So it's a bit of a stretch to talk about concrete actions today. However, the report does pull together a few ideas to highlight what policy actions and proposals are already out there, thinking backwards from desired futures, and the mapping between policies and principles. The motivation is to inspire creative thinking about how negative emission. I'm going to start that one again. The motivation is to inspire creative thinking about how negative emissions technologies and its supporting systems can be configured for growth. So here I'm going to summarize just a few key messages. If we're to stabilize climate change and meet our 1.5 degrees Celsius Paris goals, or any net zero target for that matter, significant scales of negative emissions technology together with drastic reductions in positive emissions are required. We need to translate this long-term confidence into action. But nets are complicated. We need to respect the implications of different technologies and unique project contexts. We need enough nets with the right qualities for the right reasons. Thus our call to action. We need a strategy for developing the negative emissions technology sector. Better yet, if we want to improve our chances, this strategy might adopt a co-production approach to better coordinate research, development, demonstration, and deployment. Now, in closing, negative emissions technologies will only be just a part of the deep transformations around mitigating climate change, adapting to its consequences, as well as maintaining a livable society. We have an opportunity here in the province to build on our established climate leadership and make good on our pledges. And the Pacific Institute for Climate Solutions is here to help. And with that, we'll change gears.
Thank you, Devin. Thank you for that presentation. And now it's time to hear from all of you in the audience. We'll open up the floor to questions. And if you'd like to ask a question, you can do so in the Q&A window found at the bottom of your screen. Just click on that and enter your question. And Cindy McDougall will help with those moderation of those questions and reading them out for us.
All right, thank you, Sybil. We have already got started. We have a curious group today. Thank you so much for your questions. Let's start with Taylor McCartan, who says, thanks for your presentation, Devin. Here in Victoria, the Jim Pattison radio stations are playing adverts which state that the oil sands companies are investing in carbon capture technology. Do these technologies truly exist in the capacity where their investments will offset their impact, or are these adverts disingenuous and intended to encourage us to continue burning greenhouse gases?
So first, this is good question. So first, it provides an opportunity to draw the distinction between point source carbon capture, which I'm going to assume is the topic of this of those adverts. And so that would be applying carbon capture to grab the carbon that came from fossil fuels from these, let's say it's from the upgraders there. Now that's distinct from negative emissions, where we're actually trying to take CO2 or carbon from the atmosphere and get rid of it. And so that's going back to the idea of, these words can mean different things depending on context. To speak to the point source situation in particular, because I can speak a bit to that. It's important to also distinguish between when proponents are talking about, in particular with the oil sands, as opposed to another sector, whether they're seeking to offset just their production emissions or also their product. So if they are only capturing the CO2 from their refineries, they're trying to reduce their production emissions. But when we burn the fuel in our vehicles, for example, they're not capturing that. So there's still that carbon that's going out to the atmosphere. So some oil and gas companies are proposing, to buy up a bunch of forest to do negative emissions to try and offset that. But you're going to quickly realize that there's not a lot of forest in the world for the scale of fossil fuels we're consuming. Now, that doesn't mean that point source carbon capture doesn't have a role within a society consistent with net zero, because there are still industries, for example, that are not affiliated with hydrocarbons. So, for example, cement or chemical production that have CO2 emissions, and it would be much more feasible to capture those at the smokestack or at the stack rather than trying to do negative emissions to draw those down. We have to be thinking about how those industries that are likely to remain are configured. And we need to, for example, when we're talking about negative emissions, I'm going to bring this back to the report now with a strategy. For example, we need a strategy that's going to connect our negative emissions, say CO2 streams from direct air capture, with these industrial sources in a way that works together. We can't design for the current emissions landscape and ignore the negative emissions landscape that we need in 2050. So hopefully that answers your question, and I'll try to keep them shorter going forwards.
Thank you, Devin, and thank you for that question, Taylor. Ian Pickett's says, I gather that solar radiation management is not a net. Is there a way that technologies that manage incoming radiation and/or albedo can be compared to nets? Also, any thoughts on these types of technologies in general? Thanks.
Oh, so I know it came up in the news. Unfortunately, I don't know. And I would invite you all to see what might have been released in the States as an approval for exploring that technology. So I think how I like to think about solar radiation management, it's not a negative emissions. Now, sometimes that solar radiation management, or SRM, and that's get lumped into this bigger word called geoengineering, which is kind of a boogeyman, and it doesn't really mean much. So I'm just acknowledging that word exists, but don't read too much into it. what negative emissions do is really try to reverse what we've already done from burning fossil fuels. And so if we consider that we have, for example, a greenhouse gas budget, if we exceed our greenhouse gas budget associated with a particular temperature, the only way to bring that back to a reasonable budget is by negative emissions. Now, the alternative you could do is live with that blown budget, but you could adopt solar radiation management practices, which try and reflect the sun rays away back to space. That's not going to address the budget, but if you keep doing it, and you have to keep doing it, that can mitigate the impacts or it can mitigate the amount of temperature rise that you're going to see, and therefore the impacts. So how would I say this? If you're going to do negative emissions, and you're going to do negative emissions well, where the drawdowns are permanent, you do it once and you're done. If you're trying to use solar radiation management to solve the climate challenge, that's going to be something you're going to be doing forever, and it might not be a commitment that we're able to follow through on for the long term. And the long term here means decades, centuries onwards. So hopefully that answers your question.
Thanks, Devin. Forrest Borch asks, what do you mean by a land rush from oil and gas as low-hanging fruit for CCS nets?
Yes, so within the report, there's reference to another report that was produced by, I don't remember the name, Oxfam. And so what Oxfam did is looked at the net zero pledges of the major oil and gas companies. And then they considered, okay, if they're going to do negative emissions as they say they're going to do, and they produce this much product with this much kind of emissions intensity profile, how much land are they going to need to actually sort of adopt negative emissions practices on to kind of compensate for that? And the answer is a lot. And we're talking kind of, you can measure that in terms of country sizes of land area. So the issue here is that if any organization goes ahead and say, buys up, not necessarily buys up the land, but buys up the licenses or creates agreements with the land holders to do negative emissions on that space, it's kind of determining the future of that negative emissions capacity. And we have to ask ourselves, first, the land rush, is that good, or is that being done in a way that is equitable and just for those that are on the ground? And then the other thing at the higher level is that we have to ask, is the use of those negative emissions to offset fossil fuels an appropriate use of that, or should we be, reserving our negative emissions, and in particular the ones that are perhaps more on the no regrets side of things? Should we be, not instead reserving those for those hard to abate emissions, as opposed to what might be considered luxury fossil fuel emissions when electrification is kind of here and now?
Great, thanks, Devin. I'm going to ask everyone once again, if you have questions, bottom of your screen towards the right, you'll see Q&A. Click on the button and you can put it right in there rather than in the chat. That just helps me keep track. Thank you so much. All right, I'm going to move down the list a little bit. We've got follow-up questions from two peeps, but we're going to get to those when we have a chance. Let's move on and make sure everyone gets to ask at least one. So Dave Lefebvre says, why do we stop at 100 years time frame? We know that CO2 remains in the atmosphere for thousands of centuries. Wouldn't a true net capture the CO2 for at least as long?
Yes. Yes. I don't know why why we tend to think in terms of 100 years. So when I say 100 years, that's the time frame for reporting in the protocols developed by the federal government, as well as I believe the BC government for the current greenhouse gas offsetting systems they have. And maybe that reveals something, because they're called the offset systems. And presently, we're considering in both these programs offsets. So for example, if I'm going to switch fuel from diesel to natural gas at my whatever pulp mill, I'm going to claim an offset credit because of the carbon intensity of that emission. And we're lumping those kinds of offsets together with removals. So that sets up kind of like a problem because they're not the same thing. They're not, the green stuff, if you recall from that graph, is not the same as the blue stuff from that graph. The other issue is that it creates an unfair playing field if you want to be talking about kind of the market mechanism. And so when you're talking about offsets, 100 years is maybe reasonable, right? It's not really even, you could probably even do like less than that, a couple decades. So that's probably so I think why I would speculate that we're only looking ahead 100 years in some of these protocols is that those programs are still being kind of developed from past offsets kind of thinking. Now, I would point out that there are some organizations that are taking a more longer visioned stance, and those are highlighted within the report. So, for example, they're called Frontier now, and that's a collaboration of several technology and finance companies. And so, what they're doing is that they are small in terms of their scale. It's a lot of dollars, though. They are purchasing credits on the voluntary market. So it's a voluntary market and action there. And what they're doing is they are specifically prioritizing negative emissions technologies with durability that is on the order of centuries, sorry, not centuries, millennia or longer. And so hopefully that will serve as a role model going forwards for some of the regulatory programs that are still developing.
Thank you. Michaela Newberger says, thank you for this interesting presentation. I believe you mentioned that BC is in a good geographic location to develop NETs. Could you elaborate why this is, and thank you?
Well, yeah, it depends, right? Generally we have geology consistent with geosequestration. We also have a lot of forestry lands, as well as a lot of renewable energy capacity. Now, just because we have these things doesn't necessarily mean it would be appropriate to develop them for negative emissions technology purposes. So that's really what the report wants to bring the attention to, is that we need to develop a strategy. Just having kind of the good circumstances doesn't mean it's appropriate to develop them. And we also have to ask ourselves why we're doing it. Part of actually quantifying this, however, that's more work, and that's beyond the scope of the report. What that would involve is I would anticipate a road mapping process for kind of the several technology categories that you might recall from the previous illustration, which was kind of blue and had a lot of little doodles on it, and looking at each one individually and trying to determine, what are the technical considerations on deploying this within the province, but as well as what are the on-the-ground social considerations for that as well. So unfortunately, it's a bit of a non-answer there, but I hope I've at least touched on what you're looking for.
Thank you. Rod Dobell asks or says, a very clear introductory survey, but I do not get any sense of the quantitative dimensions, the extent to which identified nets might be able to meet the estimated needs. How big, for example, does the existing ONC burial process have to be to make a significant contribution to the total required of BC? And is that scale feasible?
Okay, yeah. So the Ocean Networks Canada project, so this is solid carbon, and again, what's being proposed is to inject CO2 beneath the sea floor in the basalts off the west coast of Vancouver Island in the Cascadia Basin. The capacity for storing CO2 in this area is massive. So back of the envelope math, that would put that on the order of, let's say, a decade at least of current global anthropogenic emissions. So that's more than enough storage. Also within BC, we have resource sequestration capacity within the northeastern area, affiliated with the kind of the oil and gas reservoirs there. It's currently something that is being quantified by other entities. I believe Geoscience BC is involved with that. So it's safe to say we got a lot of storage capacity. What's going to be a bigger issue, and if I'm going to stick to the kind of the more engineered, for lack of a better word, negative emissions technologies, the bigger limitation is actually getting the energy to do it. And so we have a lot of offshore renewable wind potential. We're not using that right now because a lot of it's remote, so it doesn't make sense to connect it to us here. But that's why solid carbon, connect to it if everything's away and not making sense to connect to the grid. But just as a society as a whole, we have to consider that negative emissions technologies are going to have a huge energy demand, and we need to be planning for that energy demand as part of the bigger picture when it comes to electrifying the rest of society. So bringing this back to the report, what that means is, for example, energy regulators or the energy utilities need to be anticipating, the obvious, okay, everybody's going to start driving electric cars, but they also need to be thinking, how am I going to be delivering the megawatts and more of power to potential negative emissions technology facilities? Hopefully that answers your question.
Thank you, Devin. An anonymous attendee asks, how can policymakers in BC support the development, scale up and capacity, and the implementation of nets throughout the province? What needs to change? What actions must be taken? I love this question.
Oh boy. So I go back to kind of the first recommendation, right, is we need a strategy. So it's positive that in the most recent BC climate plan, Clean BC Roadmap to 2030, for the first time, negative emissions took like a role within that document. So that we didn't see that before. So that's great. We need to build on this momentum. Again, build an actual strategy would be my recommendation for negative emissions technologies. So that would be kind of recommendation number one. Recommendation number two is in building the strategy that would involve a road mapping process. So again, we need to be looking at all these options on the table and developing more detailed understandings of what their status, potential, and role might be within the province going forwards. And I would also challenge the government to, as policymakers, to look at more, again, co-production type models for engaging with the outside world. It doesn't help. For example, I'm going to, make it an extreme example. Just setting a carbon tax or carbon price alone does not create a sector. Okay, we need to have a more a bigger view of what we want for the negative emission sector and develop the tailored policies to get us there. I'll leave that there because that's probably a big rabbit hole we could wander down.
Thanks. Sean Lowry asks, he says, Sean Lowry here from Carbon Minerals Inc., located in North Vancouver on the traditional territory of the Squamish, Tsleil-Waututh, and Musqueam Nations. We're a net company out of BC working in partnership with the mining industry. Question, what efforts are underway in building that net ecosystem for which the report so well argues?
Not much. Not much. That's why we want to kick that off here, right? We do have at kind of the federal level within NRCan, they're developing a national CCUS framework that is, well, mainly geared towards the point sources are considering the potential negative emissions point sources as well. So not just from cement and fossil, but also say from pulp mills or potential DAC facilities that could have negative emissions opportunities. Otherwise, another example of action within the province is that PICS recently announced an intent to start a dialogue involving policymakers as well as industry participants on the topic of carbon management within the province. Again, the focus being on mainly the point source side of things, but from existing emission sources, but also contemplating the role of the direct air capture and other negative emissions technologies that could be involved there. So unfortunately, that's maybe not the answer you were hoping for. But yeah, it's still very much early days here.
Great, and I've shared in the chat sea ice's latest announcement for anyone who's interested. I'm going to move to Robin Cox. Professor Cox says, great presentation, Devin, thanks. This is very similar, so I just thought I'd connect. Where are we at with carbon storage technologies or other options, nature-based, etc., when you speak of the need for locking away for decades/centuries, and what are the opportunities in BC?
Yeah, so I talked about the geosequestration. So, we need to develop these opportunities, right? There is no, to my knowledge, there are no geosequestration sites developed in British Columbia. Alberta is much more advanced, believe it or not, on this space. For example, they've been running the Quest facility for a couple of years now at 1 million tons of CO2 going to the ground per year. On the ecosystem sort of storage side of things, that one's more challenging. The main avenue for that within British Columbia that is talked about is to store the carbon in our forest ecosystems. That raises a challenge because right now our forest ecosystems are under increasing threat from drought, pests, as well as wildfire. I would highlight that PICS has a complementary project to also another of our themes partnership program on the topic of wildfire and carbon. And I don't want to say anything that might not be accurate, but we have to be concerned that there might already be too much carbon within our forests already, considering climate change. And we have to ask ourselves, well, how are we going to stick more in there to get negative emissions goals? And so that's a bit of a problem or a challenge in how to do that. And as again, why we really need to kind of develop what I would call a road mapping strategy for all these kinds of solutions, to really figure out what kind of the potential is, and we're not just trying to get the final number. We need, because the number keeps coming up. How much do we need? Okay, do we have enough to get there? We should really be thinking about, we need more than whatever our target is. We have to be assuming that some of these solutions are not going to work out, and that's okay. We need to build ourselves some insurance, for lack of a better word, to still be in a good place, even if not all of our investments in negative emissions in every single project or technology work out. So hopefully that answers your question.
Thank you. Please forgive me, Jack, if I get this wrong. Jack Satswich says, can you speak more to the use of biomass as a net and the role that forest management companies can play in better biomass waste management practices?
Yeah, that's a good question. So the carbon within biomass would have originally come from the air through photosynthesis, and so this has the potential to be a negative emission technology and a drawdown. Within the report, there is actually there's a couple suggestions relating to what might be an idea to contemplate for biomass, and therefore the role of our forestry as well as agricultural sectors in having kind of net opportunities built into them. The short answer is, or it's not a short answer, but the one thing I would like the audience to consider today is that we have to be very careful with these types of solutions involving residues. So again, if for example, our current forestry sector is not sustainable, either because we're still cutting down old growth, or if the emissions just don't add up on the production of timber side, you have to ask ourselves whether those residues are really free in the sense that they're actually going to be negative emissions once you do your BACS or your CCS on that. So that goes back to the question of additionality and whether the LCA or the life cycle assessment of any given technology will hold once we scale up a solution. because we probably don't want to be chopping down trees to throw into a BECCS plant, although that might be what the British want to do with Drax, and that's another can of worms.
Great, thanks, Devin. We have a number of questions connected to solid carbon, so I'm going to kind of put them together. We've got not a geologist, but is the Juan de Fuca area shown in the map earlier stable enough to consider for long-term stable CO2 storage? And then also a related question, can you explain why solid carbon stores carbon in basalt under the ocean and not on land somewhere more easily accessible?
Yeah, good question. Also, not a geoscientist. In terms of the in terms of the site, I think there was a concern about stability, and then perhaps that also, it wasn't said there, seismic issues. So I'll just mention that the seismicity, the sites proposed by solid carbon are spatially distant, both in the kind of the horizontal as well as the depth dimension from the concerns around seismicity. And obviously we have experts on that topic as part of the project quantifying this. Now, in terms of the stability of the carbon, that's kind of the idea. So when we inject CO2 into these basalt reservoirs, the CO2 reacts with the pore fluid as well as the minerals within that compose these basalt rocks. And what happens is that the CO2 precipitates into solid carbonates. So chalk, for lack of a better word, gets precipitated out into the pores. Our current best guess at how fast that may occur is, let's say if we had a commercial scale injection of 500,000 tons per year, and we do that for 10 years and we stop, within several decades, we can expect most of the CO2 to be converted to solid carbonates. They're not going anywhere at that point. This is substantially faster timescale than, for example, CO2 sequestration in the more conventional sedimentary basin type sites, where mineralization, if it will ever happen, occurs on the order of millennia. Okay, so that's the stability. Now, why not do it on land? Well, the tricky part is that most of the basalt is under the seafloor. So that's where you got to go to get it. There is the unique case of Iceland, and there they have what's called the PICS project. They can only do that because they're Iceland. Most of the basalt, 90% of the basalt of interest is a little more tricky to get to as it's under the seafloor. So hopefully that answers the question.
Great. We're running out of time, everyone, so I'm going to close questions for now, but I'm going to kind of take two at a time again here, Devin. We've got Ian's asking your thoughts about a local government's role in nets. And then Leanna Warman is asking what I think may be a connected question, which is how would conservation protection of private lands from a development conversion be considered when developing a net sector policy, especially those lands that have higher carbon storage potential, such as estuaries and wetlands. And I was just thinking, since municipalities and local governments often have control, that those might be two of those types of lands, it might be two that you might want to answer together.
Yes, I would be very concerned if we had a top-down federal or provincial kind of domineering strategy for developing negative emissions within the province. I would say the recommendations, but the suggestions on what could be principles for developing a negative emissions technology strategy stress the importance of the role of really those on the ground, and whether whether it's even appropriate to develop a net. That the decision, or really what would make or break feasibility on a project, it really depends on the local project level context. And that shows up again and again in the report. I really would like people to stop thinking about direct air capture as something you put anywhere and you just throw so many $1 billion at it and it's done. Same with the forest. No, I don't want people to think that way. I want us to adopt more of a project-centric perspective when we're talking about negative emissions technologies. And that's going to help us, for one, we'll have a better idea of what the actual life cycle impacts of a particular deployment are going to be. Because right now, if we talk about, we do forestry, we kind of count the number of hectares in the province and assume, a big rough average number of drawdown we can do. And there you go. If we get more granular, we can get better ideas on how much potential there may actually be there. And then there's also the opportunity there when we start talking about projects and integrating local stakeholders within the community, or there's an opportunity there for, if it's desired, that there can be economic diversification opportunities. And there's also opportunities for knowledge sharing between those who are in an area and who might have intimate knowledge with the space and really what works in these areas. And that can probably improve the outcomes that we can achieve. That's kind of that's a big topic, and I really tried to address it well within the report. And probably too much to really give a good verbal answer for here on the spot.
All right. Well, unfortunately, we're out of time for questions. My apologies to those we didn't get to. I am going to put Devin's email in the chat, so feel free to follow up with him. Sybil.
Yeah, thank you, Devin, very much for that presentation, and for also, and thank you for the audience for joining us and for your excellent questions. And back to Devin again for your thoughtful answers to those questions. So later today, our communication manager, Cindy McDougall, who's been fielding the questions here, will send you embargoed copies of the report and brief and the presentation slides. You can view the embargoed versions as well as via the links that Cindy has pasted into the chat. And tomorrow, which is when there'll be the official launch of the report, please share the report with your colleagues and anybody else interested in climate solutions. And for those eager to get going on nets and a strategy development in BC, you'll find Devin's contact information in the chat. And remember that PICS is here to help. So thank you very much and have a pleasant rest of your day.
There we go. Nobody here but us chickens. Bravo.
Oh, okay, done.
Bravo. That was fantastic.
Thank you.
Yeah, you really nailed it. You really were very conversational, very clear, great answers to questions.
Yeah.
Really, really comprehensive, but yet not overly comprehensive, not overly detailed. And the fact that you kept referring back to the report was excellent too, to really direct people to the report. So great job.
Yeah, fantastic. I've got no notes on performance. It was
And you're
fantastic.
still recording, Cindy.
Yeah, let's
Okay.
turn that off.